Now let's check out another example. Now, like I told you guys that literally we are dealing with k plus q raised power what? And don't confuse yourself. These two things are still the same thing. Are you get what I'm saying? And like I told you the other time that these things just symbolize some certain value. Now, at that point now, we could say k represents 2p. Q represents what? Minus 3q. Are you with me? So it is still the same application of thing we are dealing with. And at that point now, if you are to apply Pascal triangle, we know that what? At the first point you have 1, right? 1. But to make things much more easier, let's apply the Pascal triangle at the end after we have expressed whatever we want to do finish. So we know the first thing you have kq, right? K raised power 5, q raised power 0, just like we had said. Now, first and foremost, we know that at this point now, k can be equals to 2p. Expressing it, making it equal. And plus our q now can be equals to what? Minus 3q. Are you get what I'm saying now? So our q can be equals to minus 3q. Now, because of this, okay, let me even change the value so that it won't look somehow. Let's say minus 3m. So as not to look somehow. So that means q will signify what? Minus 3m. So at this point now, we know what we are still dealing with is 1, now times k raised power 5, q raised power 0, plus, what's the second value under that? You have a plus 5, right, times k raised power 4, q raised power 1, plus 10, right? So plus 10 times k raised power 3, q raised power 2, plus 5 times, is it 5 that is next? Okay, 10, so plus 10 times k raised power 2, q raised power 3, plus then that becomes 5 times k raised power 1, q raised power 4, plus 1 times k raised power 0, q raised power what? K raised power 5. So at that point now, if you have to look at this would be equals to, now expressing this, breaking it down, you have k raised power 5, right, plus 5 k raised power 4 q, plus 10 k raised power 3 q raised power 2, plus 10 k raised power 2 q raised power 3, plus 5k q raised power what? 4, plus q raised power 5. Do not forget, we have put the expression there just to make things much more clear. We input our Pascal triangle there. So at that point now, what is our k? 2p. Don't forget. So at that point now, that will be equals to k becomes 2p raised power 5 plus 5 into bracket. What is our k? 2p raised power 4 times what? What's our q? Minus 3m. Do not forget. Then plus 10 into bracket. What is our k? 2p raised power 3. Then minus 3m raised power 2. The next one, plus 10. What is our k? That will be what? 2p raised power 2. Then minus 3m raised power what? 3. How you get what I'm saying? Plus 5. What is our k? You have 2p. Then minus 3m raised power 4. Plus what? Minus 3m raised power what? 5. Hope you get what I'm saying. So this is how Pascal triangle helps you also in that case. Express it first like this. Then start inputting whatever you want to do. Any crazy thing that is being given there. So at that point, now this becomes 2p raised power 5. You have what? 32 p raised power 5 plus, now this gives you what? 5, then 2 raised power 4, you have what? 16. Then you have 5 into bracket 16 p raised power 4, then times minus 3m plus 2 raised power 3, that gives you what? 10 into bracket 2 raised power 3 gives you what? 8. Then you have 8 p raised power 3 minus 3 square, minus times minus plus 3 raised power 2, you have 9m square plus 10 into bracket 2 raised power 2, you have 4p square. Then minus times minus times minus, we still later give you minus back. So 3 raised power 3, you have 27, then m cubed. So minus 27 m cubed, do not forget. Then plus, this becomes 5 times 2, or let's just put there 5 into bracket 2p, then minus 3 raised to power 4. That will become positive. Minus times minus times minus times minus. So you have 3 raised to power 4 gives you what? 81 m raised to power what? 4. So you expand it finally by multiplying others. So expanding this by multiplying others. Let's assume so let's do it sharp sharp. So 5 times 16, then times minus 3. So we have this as 32 p raised to power 5. Then you know this will be minus automatically. Minus times plus, you have minus 240 p raised to power 4 m. Are you with me? So 10 raised to power 8, you have 80. Then times 9. So that gives you what? 720. That will be plus 720 p raised to power 3 m raised to power 2 plus 10 times 4, you have 40. Then 40 times minus 27. Then you have 1000 negative 1080 of p raised to power 2 m raised to power 3. Right? The next one, you have this. Okay, we have not even expanded this last part. Plus, so you have minus 3 raised to power 5. So you have this will become minus raised to power 5. You are going to be having negative. Do not forget. So minus 243 m raised to power 5. The last part before this one, we didn't do this last part. How you get what I'm saying? So at that point now, moving on to this next one, 5 times 2, you have 10. Then you have 10 times what? 81, which gives us plus 810. Alright? Then p and m raised to power 4 minus 243 m raised to power 5. And that is our expansion in order to get whatever you are dealing with. So anyhow you want to introduce them, if you have been asked to use Pascal triangle, just remember the expression of this and induce them into whatever values you have been given to get your certain answer. Alright, now when we are dealing with the binomial series itself, you guys will be wondering that how does KQ comes together under Pascal triangle? Is it magic or is it something? Actually, it is not magic. Since we are looking at the expression at which they move, we came to conclusion that literally this is dealing with a certain expression of something like this. Are you with me? That is a certain number of combination with respect to a certain number of time at which it occurs. So that was how we were able to generate a little expression by saying, since this binomial series is like the formula for raising the binomial expression in order to avoid long calculation or long breaking things. Because when it comes to the value being bulky, Pascal triangle might not be able to help you in that system again, because you have to start thinking, what is the next after Pascal triangle? What's next after Pascal triangle? So it's while a waste time. But this is there to help you. Now, there's something fascinating about this thing is that you could apply calculator to this certain thing directly, you would have your answer. But let us understand the concept of combination first. Now, under a certain particular topic, you have what we call combination. Combination. Now, combination, there's permutation, there's combination. Now, what we focus much more on is combination, because combination deals with a series of expressing a certain particular event with no order of arrangement. So the combination we just want to move into, we are not breaking down combination because this is another topic entirely. What we just want to borrow is the expression. And what does this stand for? This stands for a factorial. Now when I tell you that I have something like n factorial. Now n factorial is just like an expression of you saying n into brackets n minus 1, n minus 2, and like that. But what do I want to say? Like I said, you're not moving into this topic. When I tell you I have 5 factorial, 5 factorial means breaking down 5 to 1 by multiplication. 5 times 4 times 3 times 2 times 1. This is my 5 factorial. Multiply all of them, you get your answer. When I punch 6 factorial, I'm having 6 times 5 times 4 times 3 times 2 times 1. So that is an expression of a factorial. So any value you are being given, any combination R, the expression, the formula or the expression for n combination R, a certain number combination, the certain value will be equals to n factorial over n minus r factorial r factorial. That is, if you have to check out now, let's say you have 5 combinations 0. And note something, please, very, very important. 1 factorial is equals to 1. 0 factorial is also equals to 1. There are proof for this, but we are not dealing with permutation and combination. Just note this, please, at the back of your mind that 0 factorial is 1, 1 factorial is also 1. Now, at this point, let's say we have 5 combination 0. You have, that will be 5 factorial now, n factorial, 5 factorial over n minus r, 5 minus 0 factorial, r factorial, that will be 0 factorial. So at that point now, you have this to be equals to 5 factorial over 5 minus 0 factorial. That will be 5. 5 times the factorial outside. You have 5 factorial, 0 factorial. Don't forget, these two things here are times those. 5 factorial times 0 factorial. And that will become what? 5 factorial over 5 factorial, because 0 factorial is what? 1. And that will be 5 factorial times 1, you have this. Which means our answer for this now will give us what? 1. That means 5 combination 0 would give us 1. So this is what we want to try to break down first in the expression. So this is the formula to utilize for this combination aspect. So we combine them in a sequential formula like this, in order for you to quickly what? Evaluate or carry out any particular lengthy calculation under binomial expression. So at this point now, if we are to deal with a certain value, let's assume we are dealing with k plus q raised to power 5. So the expression using what we call the factorial and the binomial series with respect to it will be starting from what? 5 with relation to 0 number of time, 5 with relation to 1 number of time, 5 to 2, 5 to 3, 5 to 4, 5 to 5, the last part. And with respect to this expression here, 5 combination 0, k raised to power n minus r, that's 5 minus 0. Do not forget. So 5 minus 0 will give you what? 5. Q raised to power r, which is 0. R starting from the, like we said before, 0, the lowest value upward. And we know that n, just like an expression of saying n is greater than or equals to 0, at the point at which it moves further away from it. So it can start from either 4, it can start from either 5. But R shows the certain number of time at which the n value are being given could be evaluated. And we know it's starting from literally from 0 to 5. So you have 0. Then the next part, it follows the formula sequentially. This will become, the next one you have what? 5 minus 1. Do not forget. Because R also keeps what? Keeps moving. Because after R starts from 0, R moves to 1. So you have 5 minus 1, then 1. R moves to 2. You have 5 minus 2, which will give you 3. R moves to 3. You have 5 minus 3, which will give you 2. And like that till R gets to 5. Then 5 minus 5 gives you 0. Are you get what I'm saying? So at our normal point, we have this as the expression of binomial series. So there's something that is a little bit important also while dealing with the binomial series.